Here are the solutions for semester 2 practice final number 1. Number 1, determine the domain and range and express your answer using the interval or inequality notation. All right, so we're going to go ahead and do both. Now, if you remember, the domain of a function is determined by the set of x values. And if we have arrows that extend to the left or to the right, we're going to have infinite values that are valid. So for my domain, we have this arrow that goes up and to the left. So that means it's going to come down from negative infinity and it's going to go up and to the right to positive infinity. So in inequality notation, we're going to have negative infinity is less than the set of x values, which is less than the positive infinity. And as an interval notation, we're going to have the same bounds, but we're going to come from negative infinity and we're going to do comma to positive infinity with a set of parentheses. Now for the range, this is this collection of y values. So coming from the bottom and going up, the first point I hit is right here, which is located at -4. So that's where I begin. And if you follow the function up, you're going to notice that the arrows keep going up, right, infinitely. So this is a point at -4, so it's going to be included, but it's a collection of y values from -4 up to positive infinity. And as an interval, we start at -4 and we go to positive infinity. And since this is a value at -4, we're going to include it, but infinity is never included, so we have parentheses. Evaluate using the following functions. So we have functions of g of x, f of x, h of x, and j of x, and we're going to evaluate f of 2 plus g of -4. So we can do first is independently figure out what 2 is if we plug in for the function of f. So that's where we can begin. So f of 2, we're going to use the function f. And everywhere I see an x value, I'm going to plug in 2 with parentheses. So that gives me 2 to the power of 2 plus 7. And now 2 to the power of 2 is 2 squared, which becomes 4, plus 7. So f of 2 is the sum of 4 plus 7, which is equal to 11. So I know that f of 2 is equal to 11. That's this value here. Now I'm going to calculate g of -4 using the function g. So g of -4 is equal to -3. Then instead of x, I'll plug in -4 plus 1. So g of -4 is -3 times -4, which is positive 12 plus 1. So g of -4 is equal to 13. So really, I'm going to add 11 plus 13 because f of 2 is 11, g of -4 is 13. And if I add those two together, I have 11 plus 13 is going to be equal to 24. So 24 is my answer. Number 3, solve the absolute value equation. Here I'm going to apply inverse operations and treat this absolute value, right, as the thing that I'm isolating. So I'm multiplying by 4 and I'm subtracting by 5. So the first step I can do is add 5 on both sides. And then rewrite as 4 times the absolute value of x minus 3 is equal to 5 minus 5. It's going to cancel out. And 31 plus 5 is 36. Now I'm still multiplying 4 times this absolute value here, so I can undo that with division. So if I divide both sides by 4, then I have the absolute value of x minus 3 is going to be equal to 9. And from here, it is isolated. And now I can set up two equations. For both cases, we have the positive case, if you remember, is just x minus 3 is equal to 9. And we also have the negative, which is x minus 3 is equal to negative 9. So we can have two potential solutions. And if we solve for x in both of these cases, we can add 3 here, and we get x is equal to 12 in one case. That's one solution. And if we add 3 in this case, we can get x is equal to negative 6 in another solution. All right, number 4, graph the absolute value equation. So if you remember the general form of this, we have f of x is equal to a times the absolute value of x minus h plus k. Our vertex is the starting point of where we begin this function, and that's going to be located at the opposite of h, which in this case opposite of negative 3. It happens to be positive 3 and k. So this coordinate point located at 3, 1 is where I begin. And remember that we also have our axis of symmetry that passes vertically through the vertex. Right, this is going to become important later on after we get the values left of this point. All right, we need to talk about a, and a is going to be our slope. If we have a slope of 2, that means we have a 2 over 1. For every 2 we go up, we go 1 to the right. So from our vertex, we can go up by 2 and over 1, 2 and over 1, and so on. And this axis of symmetry is going to reflect all the points across. Right, so we can go up 2 and to the left 1 and follow this along. And here's kind of how our shape of this absolute value equation is going to look like. All right, so if we insert a line here, it's going to look like this, a V shape, like that. All right, and it's going to have arrows because it's going to go on to infinity. All right, number 5, simplify using properties of exponents. So if you remember some of these properties of exponents, if we multiply same base variables, we're going to end up adding the exponents. So for this number 1, we can have x to the 2 plus 8, and that's just going to simplify to x to the 10th. And for this next one, if we have variables being raised to the power with parentheses, that means that they can distribute those. So for this one, we have s to the 3rd, t to the 3rd. If we're dividing same variables with exponents, that means we end up subtracting. So k to the 11 minus 2 is equal to k to the 9th. And if we are dividing and we have exponents inside, that means that we end up distributing the exponent to all the exponents here, and we end up multiplying in this case. So we have a to the 6 times 3 divided by b to the 4 times 3, which simplifies to a to the 18th over b to the 12th. Simplify the expressions. Your answer should only contain positive exponents. The trick to these problems is to simplify the inside as much as you can first, and then distribute the outside exponent. All right, so if we go in here and divide the numbers first, 36 divided by 18, we end up with that division. Um, 36 divided by 18. So that's independent of all these variables. And if we see that the same variables we are dividing, we end up subtracting with the properties of exponents. So a to the 5 minus 4 and b to the third minus 1. Okay? And that's all being raised to the third power. Now 36 divided by 18 happens to be 2. A to the 5 minus 4 is a to the first, so just a, right? A to the first is fine. And b to the 3 minus 1 is b squared. And now we can distribute the 3 to all the exponents. And by all exponents, I mean that this 2 also has an exponent of 1. Okay? So if you distribute that and you end up multiplying, then you have 2 to the first power times 3, a to the first power times 3, and b to the second power times 3. Right, 2 to the 1 times 3 is just 2 to the third, and a to the 1 times 3 is a to the third, b to the 2 times 3 is b to the 6, and we're really close. All we have to do is multiply out the number. So 2 to the third is 2 times 2 times 2, which it happens to be 8, and then all these variables can stay as the same. So my answer is 8 a third b to the 6. All right, number 7, simplify the polynomials, and we're going to write our answer in standard form. So first we need to simplify by adding everything that's a like term. So I'm going to use color here and say we have x terms here, here, and here. This is minus 1x. We have x squared terms here and here. And we have number terms here. So all the reds I can add together. That's going to be 7 minus 1, which is equal to 6, plus 8 is equal to 14. So 14x. Now for the blue, we have negative 12 plus 9, only adding the coefficients, and that's going to be minus 3x squared. And my number terms are left intact as 6. I didn't have to combine any of those. And now writing this in standard form, I need to rearrange the terms in order of highest exponent to lowest. So my answer is going to be 3, negative 3x squared plus 14x plus 6. All right, number 8, subtract the polynomials, write your answer in standard form. So here we have 4x squared plus 6x plus 13 minus a negative right here, 2x squared plus x minus 1 minus 2. So the first thing I need to do is turn this into an addition problem. So first I'll just rewrite the first part here as 4x squared plus 6x plus 13 plus, and then I'm going to turn everything into addition because I'll be distributing this negative here. That becomes plus. Now this one becomes minus and this is plus. All right, so we have 2x squared minus 1x plus 2. And from here you can either use the horizontal method or the vertical method. Either will work. Since we kind of used the horizontal method in the last one by identifying some of these like terms, why don't we use the vertical method here? So I'm just going to align the first polynomial here as 4x squared plus 6x plus 13. And then the second polynomial will be right underneath with the like terms. So 2x squared minus 1x plus 2. And then now we're going to add 4 and 2 becomes 6x squared. 6 minus 1 is plus 5x. And 13 plus 2 is 15. And I'm going to check if this is in standard form from highest exponent to lowest. It looks like it is, so my answer is 6x squared plus 5x plus 15. Number 9, multiply the binomials. Write your answer in standard form. So here we have two choices. We can either do the FOIL method or the box method. So whichever one you like to do the most. Here I really like using the box method. So I'll just draw it out. I have a box of dimensions 2 by 2. Where the top here can be 6x minus and negative 3, and then 4x and positive 10, and multiplying the rows and the columns. I'll have all these filled out. So 4x times 6x is 24x squared. 4x times negative 3 is minus 12x. 10 times 6x is 60x. And 10 times negative 3 is negative 30. Now looking along the diagonals here, I can subtract 12 from 16, and these add up to 48x. And my answer becomes 24x to the power of 2 plus 48x minus 30. And this is in standard form because it's from highest exponent to lowest exponent. All right, number 10, factor out the GCF, the greatest common factor. All right, between all of these numbers, 81, 45, and 9, I noticed that all of these are multiples of 9. So here the factors of 81 include 81, 1, 3 and 27, and 9 times 9. 45, we have 45 and 1, 9 times 5, and 3 times 15. And for 9, we have 9 and 1, and 3 and 3. So they all have 3 in common, but the highest number that they have in common is 9, right? We can divide everything by 9. So for the numbers, 9 is my greatest common factor. So all these are divisible by 9. And if you look at the variables, we have t to the 7th, t to the 3rd, and t squared. So at most, all of them, between all the variables, we can pull out 2 of them. T to the 7 is t times t times t times t times t times t times t 7 times. T to the 3rd is t times t times t, and then t squared is just t times t. So at most, they have 1, 2, 1, 2, 2 t's, t squared. All right, so my greatest common factor between the numbers and the variables is going to be 9 t to the 2nd power. All right, so all of these are divisible by 9t squared, 9t squared, 9t squared. And the outside number here for the outside of the parentheses is going to be that greatest common factor. So if we go number by number, first 81 divided by 9, that's going to be 9. And then the variables, we have t to the 7 divided by t squared. Subtract the exponents, we end up with t to the 5th power minus 45 divided by 9 is going to be 5. And then if you subtract the exponents again, 3 minus 2, we have t to the first, so use t. And then for the last one, the 9 divided by 9 is going to be equal to 1. And then t squared over t squared, I'm going to end up with t to the 0, which is 1. So you could say that these two cancel out. So it's just going to be, we're going to be ending up with the 1. So my answer is 9t squared times t to the 5th power minus 5t plus 1. All right, number 11, factor out the quadratic expression. In this case, a is equal to 1. All right, so we'll list out the factors of, not a, factors of c, which in this case happens to be 15. All right, the factors of 15 include 15 times 1 and 3 times 5. We can actually take care of our signs here. The empty set binomials, we have x times x to make up x squared, and a negative c and negative b means that we have alternating signs, and our negative factor is going to be bigger than the positive one. Now, how do we construct a sum between the factors that will add up to a negative 2? Well, with the factors of 3 and 5, we can make the positive one be equal to 3 and the negative one be equal to 5. And if we add those two together, we get negative 2. So that's how we check for that middle term. So that means that we have x plus 3 and x minus 5. That's our solution. All right, and the last one, factor the quadratic expression. Here we have a is greater than 1, so we need to list out the factors of 4, which include 4 and 1 and 2 and 2. It looks like we have an extra plus here, so I think it was meant to be 4x squared minus 35x plus 49. Okay. All right, let's go on with it. So if we construct the empty set out of this, we could potentially have two scenarios here where it's either 4x times x or 2x times 2x. All right. So one of the two. We can actually take care of our signs here too, because we have a positive c term and a negative b. So that means it's going to be minus minus. So in whatever case we end up, it'll be minus minus. Now for the last piece here, the factors of 49 include 49 times 1, and then we'll have to alternate this as 1 times 49. And then we'll also have to list out 7 and 7. And then we don't have to alternate the 7s because they're the same number. Now, some of these may not make sense. Like putting a 49 in this slot here, multiplying it by 4 is going to give me a big number. Same thing with here. Now, if I multiply any 49 in any of these slots, it's probably not going to end up being the same. And the difference between placing the 49 here and the one here, it's just going to be a difference of 4. So I think it's going to have to be with the factors of 7. Okay. So we could test the 7s here or here. Now, if you multiply them out in this scenario here, you'll end up with negative 14x minus 14x, which is just negative 28x, which is too small, not equal to 35. So it's not going to be this case. Now, if you test the values here, we end up with negative 28x here for the outside numbers, plus the inside, negative 7x. This one ends up being negative 35x. So that tells me that this is going to be my answer here.